Hey guys, I hope you are all doing well. I miss seeing you guys in person, and I hope things are going well for you. So I am not sure the best way of doing this without having the whiteboard, so I've written out some a couple problems we're going to do together, hopefully, and let me know if you have any questions. So this is in your workbook on page 145. We're looking at problems 7 through 9. So workbook page 145, problems 7 through 9. So we're going to start by talking about the given information that you have. So we are given that the cosecant of angle alpha is 13 over 5, and that alpha is between pi over 2 and pi. So the first thing we need to think about is, where is alpha? Quadrant 1, quadrant 2. I walked upstairs to escape the noise of my children, and they have followed me, so I apologize. In between, yes, alpha is between pi over 2 and pi. So we need to think about what quadrant is alpha in. So alpha is in quadrant 2. Okay, you guys, I'm sorry. So quadrant 2, and then we've given that tangent of beta is negative 3 over 4, and beta is in between 3 pi over 2 and 2 pi. So beta is going to be in a different quadrant. Beta is in quadrant 4. So let me see here. So that is what we're supposed to be finding with number 7, and sine of alpha minus beta. So the first thing we have to do then is draw our angles. So here is alpha. Alpha is in quadrant 2. We're given that the cosecant of alpha is 13 over 5. That tells us that sine of alpha is 5 over 13, so opposite over hypotenuse. And we should hopefully be able to recognize this as a special right triangle, 5, 12, 13. And here we've got negative 12 because it's in quadrant 2. So there's alpha. And then beta in quadrant 4, we're given that tangent of beta is negative 3 over 4, so opposite over hypotenuse. And we've got this in the negative direction, negative 3 over 4. And then our hypotenuse, we recognize 3, 4, 5. That's a pretty easy special right triangle. So now we've drawn our triangles, so we should hopefully be able to find sine of alpha minus beta. So remember, we're going to use our difference formula here for sine. So that means that we've got sine of alpha cosine beta minus cosine alpha sine beta. So at this point, we just kind of plug and chug. So we've got sine of alpha, so sine is opposite over hypotenuse, so that would be 5 over 13, times the cosine of beta, adjacent over hypotenuse, so 4 over 5, minus cosine of alpha. So be careful here, we've got some negatives that we're going to be dealing with. So cosine of alpha, adjacent over hypotenuse, negative 12 over 13, sine of beta, negative 3 over 5. And then, again, we just kind of plug and chug. So you multiply that out. You be careful with your, here you've got your 3 negatives. So subtracting negative 12 over 13 times a negative 3 over 5. So still ends up being negative then. So 20 over 65 minus 36 over 65 gives us a negative 16 over 65. So that's the answer to number 7, is negative 16 over 65. So take a minute, make sure you look through that, understand the process. You can pause the video here, talk about it with each other. We're going to take a look at number 8 in just a second here. So take a minute. Yes. Mom. Okay, you can say hi and then you need to go. Say hi. Hi. Okay. Hello. All right, now you guys need to go back to the other room. So that was number 7. So number 8, we're working with that same given information. So we're going to be working with these same triangles here, but number 8 now is the cosine of beta plus alpha. All right, cosine of beta plus alpha. So we have, remembering our formulas, cosine of beta plus alpha would be cosine beta, cosine alpha minus sine beta, sine alpha, remembering that cosine, the signs are opposite, so we have plus here, so we have got minus then in our formula. So looking back at our triangles, I'm going to put this up here. We just kind of plug and chug. So again, cosine of beta is adjacent over hypotenuse, so that would be 4 over 5. Cosine of alpha would be, again, adjacent over hypotenuse, negative 12 over 13, minus sine of beta. So sine of beta being opposite over hypotenuse, negative 3 over 5. Sine of alpha, which would be 5 over negative 12. All right, sorry, 5 over negative 13. Positive 13, I'm sorry, 5 over 13. It's still really hard for me to do this with it being backwards, I'm sorry. All right, so again, we just plugged in our values from our triangles. We've plugged them into this formula, and then we just plug and chug. So take a minute to do the math yourself. Be careful with it. Don't just write down the answer because it's here shown for you, because I can't do it with you on the whiteboard. But the answer for that one should be negative 33 over 65. So again, take a minute, pause it here if you need some time to work through the math to make sure that you understand how you were getting those values from the triangles that we've drawn. And then we'll go ahead and take a look at number 9. The last one, again, is still using this same set of triangles, all right? But now we're talking about the tangent of alpha minus beta. So the first thing that you should remember is your formula that you have then. So tangent of alpha minus beta is tangent of alpha minus tangent beta over 1 plus tangent alpha tangent beta. All right, so then again, we are just looking at our triangles. We're plugging, we're chugging. So I'll just go ahead and show the whole thing because I'm not doing a great job with that. So tangent of alpha would be negative 5 over 12, opposite over adjacent, minus the tangent of beta. Be careful here because it's subtracting a negative, which is going to end up being adding then, over 1 plus tangent alpha tangent beta. So again, here's the math. I skipped some of the simplification going from here down to the answer, but you should be able to do that yourself. I hope that this was helpful, and if you have any questions, please let me know, and I'll probably be making some more videos for other topics. So again, hope you guys are well. Let me know if you have any questions. Bye! All right.